wars, flooding, droughts. That's going to be part of our first section in our water and health course before we start getting into the science. We've got to start off with some definitions, and we're going to roll right into those definitions here. After this section, you'll have an understanding of hydrology. The hydrologic cycle will briefly cover, how to just do some basic hydrology. The focus of this course is on health, so we're not going to spend a whole lot of time on the hydrology section. With that said, if you're interested in this, there are courses in hydrology, environmental geology, civil and environmental engineering that would offer a lot more in this space. So what is hydrology? Well, by and large, hydrology is a physical science discipline. It's not like a life science like biology or ecology. So hydrology is the actual physical movement of water. It's the study of the distribution and movement of water on and under Earth's surface. Now, hydrology also has application, around the world and even in outer space, and as they look for water on other planets or on asteroids or wherever. We use hydrology in a very practical application for monitoring and predicting droughts and floods, for designing water supplies and water control structures, for helping manage irrigation waters. This is a really big deal in drought-stricken areas, much of the western United States. We also use hydrology for managing like runoff and stormwater off like parking lots and buildings. So hydrology is used in a lot of places and has a lot of application, and people who go into hydrology may choose to go into environmental engineering or civil engineering. They have a very good career outlook. With respect to water use and availability and kind of understanding some of the definitions, you're in a course we're going to be talking about water and health, and there are some important definitions no matter where you're working at in the kind of the sphere of water and wastewater. So these designated uses exist. So the Clean Water Act requires the states to have designated uses for all of the nation's waters. And when we look at the streams and rivers in Kentucky, they almost all have these warm water aquatic habitat designations. There are a few exceptions. I'm not for sure if they still hold true in Kentucky or not, but there are also cold water habitat designations that are also possible. Cold water habitats support cold water macroinvertebrates and fish, things like brook trout and so forth. Some water bodies may have multiple designations, so they may also have a primary contact recreation designation. They may have a secondary contact recreation designation. You can ask yourself, which one's probably the one that's associated with swimming, and that would be the primary contact recreation, whole body contact recreation. When you're having secondary contact recreation, you can think of things like being on a boat or fishing, where you may have incidental contact with the water. Some water bodies in Kentucky, rivers and lakes, may have a domestic water supply designation, meaning that the water can be used upon getting adequately treated for the purpose of serving like homes and industry with treatable or treated water, potable water. And then states can also develop their own outstanding resource water. So there's usually something unique or exceptional about them. And in many cases, they have an abundant diversity of aquatic life. There may be a lot of pollution-sensitive organisms or pollution-intolerant organisms present, or rare and endangered things. So those are all possible designated uses. Again, a water body can have multiple designated uses. Some other just basic definitions we got to understand are related to water use, water consumption, and even water withdrawal. So water use typically includes also the consumption of water. Not always, but it can include. I got a diagram I'm going to show you here in a second. So water consumption is the use of water in a manner in which it is not directly available for use, again, as consumed water. So water consumption is physically using the water in some way that a person who would want to use that water again would not be able to do so in an immediate or near immediate time frame. You can think of like irrigation water, people pulling the water out of the river, putting it on the farm fields, and then it'll take it a while before it actually gets back to the river, where it has to be consumed through the food product and then into the waste stream, and there's no guarantee that it'll actually go back to the same place where it would have originally been. Water use is the actual usage of the water, so it could include, using it for cooling, irrigation, so that's the example we just spoke of, commercial uses, maybe making products or something. Are there other designated uses? You can think of like withdrawing water for a drinking water plant, or you could also think of like people swimming in it, so primary contact recreation. And going back to those state laws, the habitat designations, those are uses of water. It may not be a use that may be a human-centric one, but it is an actual use of water. So let's do some comparison and some contrasting with these. So are all types of water consumption in fact water withdrawals, or are all water uses requiring withdrawal? So what makes water withdrawal? Well, water withdrawal is the actual removal of the water. Does it mean that the water has to be consumed? Well, in the case of like cooling towers, some of the water is consumed, but some of it comes back even though it's a little warm and maybe different, and is returned back to the river or lake from where it was withdrawn. So in many cases, water that is withdrawn is in fact consumed, but there are examples where a lot of the water is actually returned rather quickly back to the water supply. You can think of that through a cooling station as just one example. With respect to water consumption often involves the removal of the water and actually using it so that it may not be readily available again. And often we're thinking about withdrawing it. But you could theoretically imagine a situation where somebody may consume irrigation water where they have potentially collected it through rainfall or some other means, where they didn't actually withdraw it, they actually captured it. Somebody may argue, it's still kind of withdrawal. They captured it, now they're withdrawing it. But it's not the traditional type of withdrawal we would take from a surface water. And then there's water use. So water that's withdrawn and it's treated and used for household water, that's your domestic water supply, you're using it and so forth. But you have water uses that are out there that don't consume water or withdraw water. So think about swimming. Are you going to be consuming water when you're swimming in a lake? Or if you're engaged in secondary contact recreation? Or if you're an aquatic organism living in a stream? The designated use is protection of the aquatic habitat there. Are they withdrawing the water and consuming it? So these three terms all have different uses. So warm water aquatic habitat is a type of water use that doesn't consume or withdraw water. Primary and secondary contact recreation, they're types of water uses. They don't need any water consumption or water withdrawal. Domestic water supply, in that case you're treating water, probably withdrawing it and also consuming it, because after you drink it and it goes to the wastewater, or after you shower with it and it goes to the wastewater, it may take it a while before it gets back to the river. It's not an immediate return. All right, water withdrawals in the United States and the use of water, from a consumption perspective, it's a big deal. So public water supplies in the United States, I think this is like daily, are using like 100 million cubic meters of water per day. Agriculture uses 5 times that. So they're using a whole lot more where they're actually withdrawing water. And much of that is going for irrigation. Industry actually uses double, I'll say we withdraw in industry double the amount that we withdraw in agriculture. So where is all of this water going from an industry perspective? And the answer is, again, these power plants where A lot will go off as steam, which you could argue is a consumptive use, but there's a good bit of it that's returned back to like the river. In many cases it may be warm, or returned in some cases to a lake. So the energy industries, whether it be nuclear, natural gas, coal-fired plants, or whatever, they use a lot of, or they consume a little bit of the water that they withdraw, but they withdraw a whole lot of water. In some cases they return the majority of it back. But is this consumption withdrawal? Yeah. Is it consumption? Yeah. Is some of the water not consumed? Yeah. So, you know, just be familiar with the nuances there and those definitions. So that's getting at who's withdrawing the water. Can you imagine which of these actually is consuming the most water, meaning the water is not readily returned back into the water system? And the answer there is agriculture. The water that is withdrawn for agriculture, for whether it be livestock or if it's withdrawn to be an irrigation water source for the crops, that water is used very, very much so. It's consumed and it does not make it back to the water system very quickly. In our next video, video 2, we're going to start discussing some of the implications of our consumptive practices related to water, not only in the United States but globally, and how that is causing some consternation, some of which you've already seen in a world without water. But we'll talk about another video or a few videos in this next section. So thank you, and if you have any questions, you can always contact me at jason.marion@eku.edu.